direction. If you want to. Do you know how to?
No. Wait, Mr. Hudson, is your shirt gray or striped?
What do they call it on straight both directions?
Flag.
Crosshatch or whatever? I forget what
I
it's
got
called.
Doesn't stripe shirts
Mess
on
up cameras.
recordings?
Yeah.
Yeah.
What?
on recordings?
Horizontal stripes screw up recordings.
Why?
No,
you
something
recording
with
with your
how it
recording?
registers. I thought it was horizontal, but I could be wrong.
It's
thought it was
perfect.
vertical.
Probably. If they're small enough, yeah, because it can't figure out if it's a solid, like, light color or if it's two different
Oh,
colors.
so it constantly has to
Yeah, it's trying to alternate and figure
Then
it
it
out.
makes weird
Depends on the quality of the
math.
camera.
I'm guessing they're math curves.
They're what?
Something with math. The
Yes.
curves that it makes.
Because it's really just receiving light through the rays, and however good of a receptor it has can figure it out or not figure it out. Just like a shirt like this is probably screwing up the camera right now. So, we mentioned this briefly yesterday. Difference between arithmetic series versus sequences. What changes now that we're talking about a series? Megan.
A series has an end.
A series
Sequence doesn't.
is finite. So when we have these chairs that we're setting up, imagine the family room. We are putting 4 in the first row, 5 in the next, 6 in the next, which is nice because then you can offset them. We're going to do this for 20 rows.
Do that. You have straight.
No, we're doing it like this.
No,
What's
you have straight
offsetting?
ones. That's how it works.
Then you can see.
Well,
Because
no,
we,
because the person 2 rows in front of you is now blocking it.
yeah, but they're 2 rows in front of you, so they're less of an issue.
Not when you're my height.
I'm sorry. Sit in front.
Same.
So, how many chairs do we need? How do we figure this out?
Multiple chairs.
Okay, we need multiple chairs. This is obvious.
Add them.
3.
We could add them, and we could take a long time and just say 4, 5, 6, 7, 8, 9, keep adding.
When you do the photo, they're going to tell us.
Oh, I thought you were saying for the
Well,
next
not
round.
necessarily
Do
the
the set
formula, but the method. The method is more important than the strict formula itself. So going back to the Einstein story,
Why don't we look at the property and key concept boxes?
can we figure out how many are in the last row? The 20th row. They go for
It's
20
20.
rows.
What if it's flipped? What
20.
if you have the smallest row back?
The 20th.
Then you just
Then
reverse
I'm
the
firing
rows.
you from setting up chairs. So, Michelle,
You can do the sets thing, like how last time there were like sets of 101.
so how many are in the 20th row?
20.
If the first row has 4, and we have 1 every time,
Never
How
mind,
many
I thought
times-
that was the 4th row.
how many times
Yeah.
are we going to change rows?
20.
19. To get to 20, we're going to change 19 times. So we start with 4, so we can just say
17.
row 20 is
17.
going to be 4 plus 1. This is kind of redundant to say the plus 1, but that's what we're actually doing.
Ooh.
20 minus 1 times. Because there are going to be a total of 20 rows, which means we change 19 times. We change by 1, and we started at 4. So then from there, because I got to get his events for the track meet tonight, then from there, use that Einstein method to figure out how many we'll need in total based off that set method. All right, you run what?
How fast is mine?
Only 2 events?
The fastest is 6:37.
Faster than me. So only 2 events?
Yeah, I used to do a third, but I was kind of.
Yeah, just tonight. Yeah, cool. Thanks, man. I realized that there was wetness on my desk and wanted to
Wetness.
avoid it really quick.
Wetness.
From my coffee. From my iced coffee. Megan?
Okay, if you had chairs wrapped around the, or, so like in a sphere, would that be a series or a sequence? Because it technically keeps going, but there's only a finite amount. This is
Well,
what
if
I
you're
learned.
if you're talking realistically, it's finite. It would have to be finite.
So it'd be a series.
Yeah. Eventually, once you reach the, I mean, you'd fill up the world with chairs. Like once the whole world is filled with chairs, it's finite.
That's no problem with chairs.
Why do you
I'd
put
like
it
to
on
fill
space?
the world with chairs. All right. So how many are in the 20th row?
I don't think it says chair. I think it says something else.
20.
What does it say instead of
Three.
chairs?
3. Be
I was
careful.
close
We
enough.
only add 1 19 times. So then, if I took the first row and the last row. Brian?
So back to Megan's question, right? So if you filled the universe with chairs, right? It has to be finite, but the universe is expanding. Right? So it'd
yeah, I
be
was about to say, we
infinite.
don't, the universe
Yeah.
is not
But it'd
finite.
be
But it's
finite
still-
for an instant,
Wait.
right? It'd be finite like for a split second, and then
No, so this is where the idea of infinity and the tangibleness of it conflict with each other.
Over.
So,
No.
we don't have, I'm sorry, but for getting in what we need to before spring break, we don't have time for this tangent today. After spring break, we're going to do projects and delve deeper into these things. And if you want to go deep into the idea of infinity, we
No,
can.
That's
But
like-
not, right, like, not everybody.
That's
But
tricky.
just,
Yeah.
Chad, I'm not going to talk over you because they're reading over. But for now, we have work to get through. So we're going to continue on with this. That is a good question. We can go down that route at some point. Not today. It's a decent question. I mean, like it gets into the theory behind math, which is hard though, because the tangible, let's do math, is easier than the theory of how do we derive it, how do we, approach these problems. So if I take the first row and the last row, those together would be 27 chairs. How many sets of those would I have when I take a chair away and I move up a row and I add a chair and move back a row? How many sets? Yeah, because it's the 20 rows divided by 2 because every set is using 2 of them. So that will be 10 times the 27, and we would need
Wait, what? Back up.
back up.
I'm confused.
So where?
to get rid of the -1 and the other side.
We took the first row of chairs. Let's say we're now taking chairs down. Although we know how many were set up. But let's say we're taking chairs down. One team starts at the front, one team starts at the back. And now obviously this doesn't make sense. We each take down a row at the same time. So you guys take down the front row, we take down the back row. We took down 23 while you took down 4. Then we move up a row. And you take down 5 while we take down 22. Still, we took down 27. We move in another row. We take down 21 while you guys take down 6. Still 27. So that's where the 27 comes from, is those pairs of rows, like Einstein when he took the lowest and the highest and then worked his way in. So then we say, how many sets of those are we going to have?
Oh.
Well, we're doing 2 rows at a time, and there are 20 rows to get through. So we'll end up with 10 sets. So we get 10 times the set of 27 to give me a total of 270, and that's where we derive the formula that
That's how
we
many
use
chairs there are?
in total. Now, if you add 4 plus 5 plus 6 plus...
Why do we
Actually, do this. If we do... never mind. Factorial is multiplication, not addition.
Why do we add another row though if it ends at 20?
We didn't add another row. We used the first row. This is the 20th row. This is row 20. You with me through that?
Oh, we added
This is row 1. We made a set with our longest row and our shortest row. Then we bumped in the next longest and the next shortest, which still equals 27. So this goes back to 15.1, where we looked briefly at how do we deal with trying to sum a set. We can take 2 of the sets, line them up, get the same values, and then we divide it by 2 because we had double the sets. Now instead of doubling the set, we just take the first and the last together, work our way in all the way to the middle. Because this is even, it'll work out with perfect pairs. If it was odd, we'd end up with 1 row left in the middle, which would be compensated if this value came out to have a half involved. That middle row would be 27, or half, well in this situation it doesn't make sense, but that middle row would be half of whatever your sets were, because it's the 1 left over. Brian?
So the 20 over 2, that's the number of rows.
How many sets? How many rows by how many we use each set?
Okay.
So you could make larger sets, but we don't need to. Like, it's just simple to make a set of 2. So let's do a couple more. I wish that I had captured. You guys were close on the calibration. So this is where that comes from. Or this is like what we do with that. N terms divided by 2 times the summation of your lowest term, or not summation, but the sum of your lowest term and your highest term. We then are going to start to use sigma, and we'll get there. But sigma is when I just said summation. Sigma is what we use to sum an entire set, or whatever. Yeah. So let's say we have all even integers. So 2 to 100. We know that every set that I could make, lowest and highest, would be 102. Because then if those disappear, 4 and 98, 102. 6 and 96, 102. Excuse me. So we figure out there are 50 of those even integers between 2 and 100. We divide by 2 because of how many sets there are. Multiply by 102, we get that the sum of that would be 2,550. Questions? So what about this series? Now, it's not just evens. We don't know right offhand how many terms there are. So Ethan, what do you think? How do we figure out how many terms there are here?
You take the last term. No, you take the first term, subtract it from the last term,
Okay. You could use the sentence you had started, but yeah, you're right.
and you find the common difference, and you divide.
That wouldn't give you, well, so you just told me to subtract this. Sorry, and that gives 95. That's not the common difference.
No, I'm saying. What?
You should take the first term and the last term.
And you take 95 and divide that by the common difference.
Okay, so what's the common difference here?
5.
Okay, so 95 divided by 5. I'm trying to work with the offness, and it's not really working. What's 95 divided by 5?
It was not this awful.
A
Oh,
number.
19.
19.
That's how many terms there are. Is that not right?
What does that tell you? Let's compare that.
That's how
How
many
many
terms
terms
there are.
And that's what he's saying too. Is that how many terms or how many changes in the term?
Changes in the term.
So, that's what I'm asking.
No. that's
What
not
does
the
this
terms.
get you?
That's the number of terms.
So, we're saying there's 19 terms here?
I just thought you were trying to tell me I was wrong.
Because if you took
No, I'm just trying to make you think critically about what you're doing. You took the total difference divided by the common difference.
Do 99 minus 5 19 times.
Yeah,
Let's compare it to one that we already know. We know this has 50 terms. Sometimes I know what I'm talking about. So, from 2 to 100, your total difference there was 98. Our common difference was 2. That gives me 49. Because that's how many changes there are. So this 19 that we got, is it number of terms or number of changes?
Number of terms.
Dude, are you paying attention?
I got it.
Not really.
Yeah, I can tell.
Yeah.
So do you need to move?
98? No, I'll just put my pen away.
So,
Not away, but out of my reach.
we just compared it to problem 1 that we already had solved. We already knew how many terms there were.
Wait, so I was right?
No.
In the first place, I was.
No, because in the first place you said it's how many terms.
No, I said change the terms. On my
that's
second,
the second
my
place.
third guess, I said. I just kept alternating.
Which is the problem. You have no confidence because you're not stopping to think. So stop to think. We went back to compare this with even integers. We know from 2 to 100 there are 50 even integers. Count them up if you don't believe it. So we have 50 terms. We take our total difference divided by the common difference, and we got 49. 49 is not how many terms we have. It's how many times we changed the term. Think of what you did. You found a unit rate, essentially. You took 98, which was the total difference, divided by 2, which is the individual difference. This tells you number of times, number of changes, number of jumps, number of differences that happen.
So I was
You
right.
mean 95, not 98?
No, this.
Oh,
not
okay,
not
sorry,
the
sorry.
problem 1 got it, but the one that we knew that there were 50 terms. We were trying to compare it with something that we know. So this 19 tells me that's how many changes there are. So when you do this math, you have to add 1 to
Oh,
get
wait,
20
oh,
terms.
I thought I said changes. Oh,
I
okay.
didn't know it.
What?
I had that.
So did everybody. Sorry, we had already gotten that.
No, we didn't.
Yeah, we did.
Shut up, Caleb.
So then, Brian, would you like to tell me how to find the sum of everything?
No.
Is not.
How can I figure out how many sets I would get?
Oh, would it be half of the 20?
Yeah, so my sum will be the 20 terms divided by 2 because I'm going to pair up my sets. Then I need to multiply that by what the sum of the set is, which is 103. Pretty hard math.
Oh, if you add the 4 and 9.
Right.
So then this becomes 1,030.
That's like one more than 1,029.
You're right.
Wait, what?
You said 1,049?
That's what I heard.
No, you said 20.
So
Oh, I was
he, no,
like,
he said 29.
That's the same.
Like 19.
Oh, yeah.
49.
So, let's say you guys actually land a job. And this company
That
pays.
is not subtle at all.
McDonald's is a job.
Do you work there?
No.
Why are you mad at me? So
I
a
said
company
actually.
pays $10,000 bonus to salespeople at the end of their 50 weeks. That's a long time. That's like the whole year, essentially. Put it down. So, if they make 10 sales in their first week and then improve their sales by 2 each week after. Because if you stay stagnant, you're not getting better. Really, staying the same is like getting
I
worse.
feel like in sales, you want consistency.
So, take like a tool salesman. Once he has a client, he's going to keep stopping back by there, replacing their broken tools and stuff. He should be landing more
But
clients.
not every week.
Yeah.
It's kind of what's expected of you, yeah.
What the heck?
But that's all.
You gotta keep making, you have to keep making the company make more money.
So in
Not just
by
the
their
same
model-
Caleb,
By
Caleb.
their model, their perfect person would make them infinite amount of money.
Yes.
That's-
Caleb.
You should be exponentially beneficial for a company,
Caleb.
is what they look at.
My dad always tells me this whenever we go someplace. The only reason a company is to make money, nothing else.
Unless they're a nonprofit. But then it's not really a company.
Then they make money.
But still, they make money. There's a
They just put it
nonprofit.
back into the business.
They just put it back.
So, we know that every week, they gotta sell 10 plus 2 more for every week that they've been there. Well, every week they've been there minus 1. So we set up our 50 weeks minus 1 for 49 changes. They're changing by 2. They started at 10. By the end, to get that bonus, that 50th week that they work, which is almost a year, they've got to have 108 sales in that week.
I mean, depending on what they're selling, they're probably going to make more money off the
Yeah.
selling of the 108 items than they would off the
Now, this could also be a contract that you sign when you get there that says, I'm going to perform at this level, or at my 1-year review, I could be let go. There are clauses like, so depending on where you go into work, you got to read those contracts that you sign. Because then, because if they fire you without just cause, you can like come back at them. But if you sign a contract saying, yeah, we'll fire you if this is how you perform, then they have nothing to worry about. So if they want an easy way to get rid of you, there you go. Somebody's outperforming you, you're out.
Wait, so companies can get in trouble for firing people?
Oh, if they don't have a good cause.
Yeah, that's what they have
I mean,
to
if
do
you're like
for.
stealing stuff from the
Well, yeah,
workroom,
that
sure, they
happened
can
in the
fire you. But if
office.
they just fire you because of like,
They even
What
have
if
like
they downsize it?
Because they don't like
Would that
it.
When
still
Andy
be
turned to fire
They don't like your shit.
bad?
that goes far deeper than my direct knowledge.
I just know
Talk
a
to
lot
somebody
of
in
companies-
HR. I can connect you to somebody in
Oh my
HR.
Don't they have
know
to
a lot
like
of-
hire some like special person to like tell them what's going on?
Yeah, HR, human resources.
That's what my
They
my
take
dad's-
care of
Oh.
making sure that they stay, you know, on the straight
Don't
and
they give
narrow.
like 6 months like sort
Yeah,
of?
they'll give you. There's severance pays, or there's like exit packages, where it's like so severance pay might be that they just pay it once, or they might keep paying you for a certain amount of time to help you get on your feet, or they might connect you with the next job. Like there's a bunch of ways they can protect themselves.
Right.
So to sum this all up, so let's look at how beneficial you actually were for the company, right, Straveler?
Yeah.
So if you sold 108 that last week, and every week before that you were selling, 2 less than that, We can sum the whole thing. You sold 2,950 sales for that company in all 50 weeks. Now, after those 50 weeks, maybe they say, okay, you're fine, you're doing great, then you can stay consistent where you are or have some fluctuation. Who knows what the contract would say then, but you've sold almost 3,000 of whatever widgets. Yeah, we don't use the S this. So try this. You're going to get a $5,000 bonus if at the end of your 50 weeks, which is pretty much a year, there's 52 weeks in a year, make 10 and improve by 1 sale. A little bit easier. You only have to get 1 better every week. What is the total in week 50? What's the total of all 50 weeks? Sorry, I don't know why this is not this side. I would always suggest writing the formula first without the numbers plugged in to remind yourself until you get very comfortable with it. Anyone lose a water bottle? He's very scared. He's all alone.
What does it look like?
It's a pop there. Well, not really. They're like 30 years old. Because it was probably out before I was there. Really old animation. I was watching Claymation not because it was cool, but because it's what they had to work with. Would anyone like to come show this? Ryan, you want to come up?
Oh, I can so
Do you really think you can?
I think so.
Alright. As long as you're confident.
45.
I was showing you guys the whole calligraphy thing. If you want
Is
your
it not a
writing to look fancy, after you pick up the pen, click on this, which sometimes you have to click slightly below or slightly above, but that'll make your writing look a bit fancier as opposed to
Will
just
it
a
make
marker.
it any neater?
Yes, I use it because it makes it look neater.
It's with all the
You're on
Greek
board.
stuff at the bottom. Alright, so you would start with the
There's the different tools inside.
okay. What are these weird symbols that look like maybe 10? Oh, plus. Mine is Uno. The power, or not the power, is times 1. And then you don't have to have that though, because that's not important. And then you just the
So,
49.
if he was applying the formula directly, the 1 would be in front of the 50 minus 1, because that's the change.
59.
Times 49. Let me
So,
see.
see.
What?
Means
You
what?
have to say.
Here, Ryan, do you
I'm
want
kidding,
to
Brian.
For
Keep
sure.
on going. I got it.
No,
I got it.
thinking
Same
it out
thing as you.
first.
Keep
So
on
then-
going.
I was actually
I
knows
keep
this.
going.
Brian, I'll go.
Okay, wait.
Tag team.
No, I know what to do. Do you want me to
Brian,
keep going?
Yeah.
I don't know what's going on.
He's
today. I
asking.
don't know why we're trying to put such little effort
Here,
into
Brian,
this.
do you want me to?
This is what we're doing.
Do you want me to breathe
So,
what you
to
did?
find the sum of
And
it,
then-
is
Ryan,
this.
why does your
So
9
that's
look
the
like
sum.
8? Shut up.
If we
I
gotta
need it,
find
Brian,
how many
they
we
don't
made
know
that
where-
last
I
week,
get
because
it.
we don't
Oh,
know
no,
how
I'm
Why
many
would you
we
get
did.
every
That's what
It
you
looks
do.
like a golf.
No,
So then you would have to plug that into the
There were
formula
10
you got
sales
for the second
plus
part
the
to
change
find
of
out how
one,
many you sold.
49 times.
And then you
So
would just do
this
the.
right here.
Brian
How
is
many
teachers usually face
How
your
many
students.
times
I can't face it right, Caleb.
and what
Well,
is
no,
that?
you face one.
This is all on
you
camera.
say
I'm
right.
so watching this again.
50 over 2.
Write some stuff down.
And then-
so we can check.
Brian, why do you write so big?
Plus 59 with that.
So, did you already figure out how many in the last week?
Yeah, 59.
So,
And then you do that, and then that's plus 25. Oh, you have something to add.
no wait, if it was 59 in the last week.
Yeah.
Are you a lefty? I never realized that. Writing on the smartboard left-handed, you should really be flipped the other way. By the way.
Okay.
Like, because I'm right-handed, I do it from this side. You should honestly be over there with help. So, I agree with the 59,
So then you would plug it into.
but to do the summation of everything, I'm trying to write too fast. Yeah, there it is. So let me write this a bit fancier.
25.
Can you rewrite it?
9.
If he wasn't so ambivalent to writing on top of things, it would be okay. Like, it's not the fact that it's so big, it's the fact that you're on top of stuff. Give me a second. Let me rewrite this for you. Everything you did is right.
Yeah.
So, right here.
Why is there a square root?
Wow, this is long.
It's 69. Yeah, you have to add 10 to the 59.
So, right there. Guys, I need your attention. He's saying, how many pairs do I have? I have 50 weeks. And if I start pairing the first and the last, and then I bump my way in, I divide by 2. It's going to be that many pairs times.
See, he broke it, I didn't. I'm obviously better.
It's also because you gave him absolutely no room to work with.
I think
Where'd
you
it
broke
go?
it.
You got to.
I don't know what's such a big number.
Oh.
Maybe we should just.
Why does it not recognize the eraser? There you go.
I think it's because it thought you were tapping on the top of the.
Yeah, because if it's the
I think we should
Oriented it wrong.
No, it actually was fine, and you were the one who oriented it.
Well, Brian scribbling all over the whole thing doesn't help. But
Green looks like a gun.
He just,
now it's easy. So that gets multiplied by what the value of each pair is. You guys already found out that he had 59 sales in the last week. He had 10 sales in the first week. So that becomes 69 times 25, which gives you a summation of what?
17.5.
I literally just skipped the entire thing.
Is it 17 or
It's
10,000?
1725.
17,
Yeah.
25? Okay.
Oh.
Do you know?
That's not
Oh.
10,000.
I said
Got it.
Oh, okay.
Did you write 10,000?
25. What?
I'm going to reorient this. Check out problem 3 real quick.
Wait, was
No,
that
she
the
wrote
answer?
17.
Dude, there's fancy numbers.
Wait,
Wait, no.
wait, Rob. was
Yeah, that was the total of all of the sales that he had made.
I literally just skipped.
Why do you add 10 to it?
Because that's the beginning number.
You
And
add
that's
the
what you start
first
with.
value
I
and
just
the
know
last
it means
value,
some.
and then
It's
Because
10
that's-
and it's 59
oh,
dollars.
the first
Right.
Wait, can I ask you-
What
wait,
are
yeah.
these college symbols?
I see.
Wait, what does that mean?
Yeah.
So,
Sigma.
this is sigma, our best friend when we are using summation.
Or something.
Sigma is just really giving us a platform on which to place our values, telling us what to do. Can anyone figure out what this might be communicating? We've got the same sigma everywhere. We've got some expression in parentheses. We've got a number on bottom and a number on top. Traveler?
Actually, I forgot one.
Walker, do you have your hand up?
No, I'm good.
Calvin?
Okay, I'm not sure what the bottom part is. Bottom.
Okay, they're all the same, so that makes it tough.
The top part, I'm pretty sure is the number of values in the series.
So it'd be number of terms?
Yeah.
Yeah, last
And
term?
then the right is the rule based on term number.
So
the
which of
explicit one.
these would work here?
Hey,
Yeah,
Yes.
that's
A?
Yep.
So how do we know between A and B? How'd you figure out how many terms there were?
me or something.
Magic.
Michelle?
You take the difference in the 207 and 7, and that gives you 200. And then you divide that by 4 because that's the common difference. And then you get 50, but that's the changes. So to get the
Ooh.
terms, you add 1.
So that's the change in terms. So we take that, we add 1, we find out that there are 51 terms. So, just as Calvin said, I'd love you guys to notate the pieces of this. This is your start, which right now seems dumb since all of them say start at 1. You don't always start at 1. Let's say we're doing a model for population, and we're going to talk about the population growth between 1990 and 2007. Unless your model starts the function at 1990, which it probably doesn't because we didn't start at 1990, you would have a model that needs to start somewhere other than 1. So when we start, we're always going to be starting at 1 to keep things easy for you guys. When you get into the application of this, there's many, many times that we use this and we don't start functions with an input of 1. So this is our final term,
So
and this is our rule, or whatever you want to say. Function, rule, operation, logger.
Question. So is this at the point in math where it starts to like I'm trying to read Greek instead of I'm trying to understand numbers?
No, not really. Pi is
Yeah,
a Greek
but like-
symbol. E is actually.
When there are more
How do
Greek
you find-
symbols
where's
that are
the
on
E
numbers, I feel like at that
Oh,
point we've reached another level.
Well, I either need to go back to some basics with you or something, but there aren't more Greek symbols than there are numbers.
No, I'm not saying now. I'm
Like-
saying like in the
I
is
think
this
he's
where it
saying,
starts to get to the point where I'm trying to read Greek instead of read numbers?
So I mean, a little bit. If you wanna talk deep, complicated math,
That's stuff.
let me show you my abstract algebra notes, which are actually back there beside you.
How do you get an E?
Mr.
In one of those
Hudson,
notebooks, I forget.
why did you just like grind us? Where do you get the E?
Ah, so
it's second
that.
LN.
So are you talking about the sigma or an E? Because
The
sigma's not an
sigma.
E.
Oh, sigma.
Well, I mean, it's close
You
enough.
don't on those calculators.
Oh.
Sure, but we don't need to plug it in. We'll get to the point where we do plug it in, we use the calculator. But when we look at that, we can actually, from there, just use our knowledge base to solve this. So we know that our rule is 4n plus 3. We know that 207 is our final term. We know that there's 51 terms. We could figure this out manually. We don't need to plug sigma into the calculator. We could just do our pairings, our groupings, and figure it out just like we did the other ones. But we can, we'll get to the point where we're using the 83s to do this.
I'm still kind of confused about that n equals 1.
So that is saying start at the term value, start at the input of 1. So the first output that we're using is 7 based on inputting 1 to this rule.
Okay.
That's how we got our 7. So if our start value was actually 15, we'd be starting, like, if the same rule applied, we'd be starting at n equals 3. So we don't always start at term 1. So
And
just
that's
like population
input
models.
the term number.
Hmm?
So that's just input the term number.
So your inputs are now n instead of x, or whatever. So, try this. We don't need to find the sum. We're just trying to write it in summation notation. We're just trying to understand how that works right now. So go ahead and make your sigma. Like I said, it's just a platform for us to put the values. So we are going to go ahead and name this term 1. We don't actually know if it is term 1, but for our notation, we're going to make it be term 1.
I know how to do it.
You do?
So you do 268 minus -5, which would be plus 5, so that would equal 273, divided by 7, because that's the common difference, and that equals 39. And then because that's the number of changes, you add 1, and that's 40.
Any questions on how we figured out the 40 terms?
How'd you divide by 7?
Because
Because
that's the
it's common.
common difference.
Oh, okay.
So it's total difference divided by common difference. You're just doing a unit rate, essentially. 39. Then we add 1 because that's how many changes. That's like cuts a pizza, or, well, cuts on a piece of paper versus how many pieces you get out.
Yeah.
3 cuts gets me 4 pieces.
Or like when you're trying to draw a chart, you gotta draw.
Yeah. Yeah, so if you start with this, 1, 2, 3, I now have 4 sections. Perfect. Well, now we need the rule. So we just put a 40 on top. Now there's no n equals or anything on top. Really, we also use that so we know what in the rule is the input. So we're just saying the input here is n, and we most often use n. We could do, we could say -5 is our start term, but it's easier not to. What's it easier to use?
268.
Went the wrong direction.
-5.
It just said that we could use -5, but it's easier if we use something else. Why did they use 4?
Because that's the common
difference.
No, the difference is 4.
Oh, they just went back.
But, or, sorry, why'd they use 3?
They
My
went
bad.
back.
Oh, because they went back.
They
-12.
went back a common difference. Where are we? Right here. So if we instead, I don't love that they do the 4n. They did their 4n. We could do 7n first, but in my brain, and this is just a me thing, so if you do it differently, that's perfectly fine. I like to say my first value that I'm working with, and I'm going to use -12 because I go down to term 0, and then we add 7n times. Now you can write it 7n minus 12. Does not make a difference. But in my brain, I do it. Where are we starting? What are we doing? Now we know that when we write expressions, we normally put variable values first and higher powers first, higher order. So you do want to be able to and be familiar that we would rewrite this eventually, and when you get good at this, that's like your simplified form. But when you're working to build these, your thought process should be this, even if you then write it down and look around.
So why is it easier to use -12 instead of a negative?
So, if I wanted to use -5, this rule would actually be
Oh,
-5 plus 7 times n minus 1, because it hasn't happened, I didn't add the 7 to get term 1. I was at -5 to get term 1. So then, if I distribute this to simplify, it actually becomes 7n and -7, and that -7 takes your -5 down to a -12.
So it just
It's the same thing, just simplified.
Okay.
Yeah. Calvin?
Why should that be your thought process?
Like I said, it's a me thing. So I think about, I'm starting down here because, I mean, you have to know your common difference before you go there. So I don't know. That's
The way
it.
you
Really
were
is a
saying
me
it
thing.
is like you should write it like that, but your thought process should be that.
Yeah.
Like
Yeah,
like
that-
it's supposed to be, not like it's a you thing.
Yeah. Sorry, it's a me thing, and that's how I do it. But then to write it, you end up writing it like this. So it's thought process versus what you end up with. But however it works for you. Are there questions on how we figure out the difference or how we figure out term 0? Or you can just distribute, but it takes another step. So if you want to do it the longer way, you can.
Where does the E, like the fancy E, do?
It's not me.
Okay, it's the
Sigma.
sigma. Okay, what does it do?
It just
So-
represents summing.
Wait, is it sigma or
So
Sigma.
it's the shorthand notation. And now we're like out of time. It's the shorthand notation for saying there's actually a ton of numbers out here. And what those numbers are, like this actually equals
Okay, so it's just like representing all those numbers in a small thing.
Yeah.
Okay.
it's put it all together, the inputs of 1, 2, 3, all the way up to 70. So to write this out, you'd have 70 values written out added together. We don't want to do that because we work more efficiently than that.
Do you have one?
Yes, they are right here.
Why is that binder so
Chaos theory. I probably can't.
Dude, the universe has probably already expanded like 4 miles since the beginning of class.
I
It's a-
probably
it's a
know
little
it
more
expanded in infinite amount.
Only 4
Yeah,
miles, guys.
No, it doesn't. It wouldn't expand an infinite.
Literally says
No, it's not.
Okay, you can
No.
Leave into that for a second. You are welcome.
It expanded.
I know.
Who doesn't have this yet?
It's already added.
I don't think I do.
Who else needs the homework? I got one more.
Are we wandering or all?
Oh, odds or evens? Evens or odds? Choose what you want.
It's a finite number right now.